Hello everyone, welcome to the study of complex mathematics. Today's consideration, it is what is called Cauchy residue theorem, whereby it is applicable when you want to find the residue at a circle. And this is how it is given: integral around a circle of complex function of f of z dz is given by 2 pi I sums of, then you sum all the residue up to n, or you sum all the residue up to n, where summation of this R is the sum of the residues R1, sum of the residues R1, R2, R3, all the way at the poles alpha 1, alpha 2, alpha 3, all the way to alpha n. This is all the way to Rn. That is Cauchy residue theorem. Now, in case if there is no pole inside C is the circle, the pole could be inside on or outside. It could be inside on or outside. In case there is no pole inside, then the sum of these residues, the sum of the residues will be equal to 0. And the Cauchy residue theorem reduces to the following. It reduces to f of complex function z dz is equal to 2 pi I multiplied by 0, which is equal to 0. In case there is no pole inside C, whereby C is the circle. So that is what is referred to as Cauchy residue theorem. So you can be told to use Cauchy residue theorem. Remember, C here is the contour at pole Z. So that is all with the Cauchy residue theorem. In case you are considering a single pole, Cauchy residue theorem will be given by the following: integral of C f of z dz is equal to 2 pi I r alpha, where alpha is the pole at z is equal to alpha. Alpha is the pole at z is equal to alpha. Remember, pole, it is a point where the function is not defined. Now this is for the case where the pole is at z is equal to alpha. In the other ones, this function f of z is bounded by a simple closed curve contour boundary C, except that the pole z is equal to alpha inside the circle. So RZ is this one, R alpha, this one is the residue of f of z at z is equal to alpha. And remember, we said the residue is given by limit as z tends to alpha of z minus alpha, you multiply by f of z. That is how you obtain the residue when you are dealing with a simple pole. So thanks so much for your time on residue. For more such learning, tune on to my YouTube channel so that we may learn together. Bye bye. See you in the next presentation.